In this video, we will go over alkynes, which is a triple bond, right? A triple bonded molecule. For instance, we can have a molecule that has a hydrogen attached to another carbon that is triply bonded to a carbon and a hydrogen. Okay, so since we have two carbons, you would normally think that this is going to be an ethane, right? But with triple bonds, they change the ane to n what? To yne. They change the ane to an yne. So this will be called an ethyne. So whenever you have a molecule that has a triple bond, you replace the ane with an yne. So you can have propyne, right? Butyne, and let's say hexyne. So normally you would have propane, butane, hexane, but when you have, a triple bond, it changes. You'll have propyne, butane, hexyne. You just replace the ane with a yne. Alright, so the main difficult thing that you'll encounter when you're doing alkynes is that you can't see the carbons normally. But I'll tell you up front that this has 5 carbons. This is 1, 2, 3, 4, and 5. If you can't see that, then let's actually enhance the image. I have a carbon right there. And hopefully now you can see it. This little break right there is a carbon, and this is also a carbon. And so we have 5 carbons, right? And we have 5 carbons, so it's what? Pentane. But since it has 3 bonds, this is triply bonded, is going to be pentyne. Pentyne. Okay. Now you probably noticed that I numbered it from right to left. I did this because if I numbered from left to right, we would have this. And of course, I'd rather have my triple bond on 2 and 3, because 2 and 3 add up to 5. But 3 and 4, they add up to 7, right? And 5 is lower than 7. You always want the lowest number for your double bonds or triple bonds. I mean, that's the method I use. If you just want to be straight with it, just say that going from right to left will give you a double bond on 2 and 3 instead of 3 and 4, right? And you're probably wondering, well, do we say 3-pentyne? What do we say? Well, we use the lowest number to name our triple bonds. So we're not going to say 3-pentyne. Instead, we're going to say 2-pentyne. So we use the lowest number, the smallest number, to name our molecule. So there are 5 carbons, so we know it's pentane, but there are 3 bonds, so it's going to be pentyne. There's a triple bond between 2 and 3. We're going to use the lowest number. In this case, it's 2, so we will say 2-pentyne. If you're having trouble seeing the carbon, just rewrite the structure. Just rewrite it. Of course, everything takes practice. Okay. We have 1, 2, 3, 4, 5. We have 5 carbons. This is 1 carbon. That's another carbon. Another one right here, and 1 right there. Alright. We have that. So let's write. Let's write it out. Well, where do I start? You would probably assume that we start from left to right, because, a triple bond is more important than a double bond. Well, that's not right. That's not correct. Actually, double bonds are more important than triple bonds. So whenever we have a double bond and a triple bond, we will start at the double bond. But that only occurs if there are equal amount of carbons. Well, not equal amount, but it's better to show you. It's better to show you, right? So if you start from right to left, we have 1, 2, 3, 4, and 5, right? And if we go from left to right, we have 1, 2, 3, 4, and 5 as well. So really, it does come down to preference. It really does come down to preference. I'd rather have a double bond on 1. I don't want it on 5. Triple bond, it's okay to have it on 5. It's not preferred. But if the double bond has more importance, you're going to have to do sacrifices. You're going to have to make that double bond priority number 1, right? So we number it from left to right. We number it from left to right. Or from right to left, sorry. We number it from right to left. And we have 5 carbons, so this is a pentane. But now we have a problem. We have a double bond and a triple bond. How do we name it? Well, since the double bond was more important, we're going to name the double bond first. We will say that this occurs at number 1, carbon number 1. Again, we use the lowest number between 1 and 2 to say the location. So I'm not going to say 2-pentane. I'm not going to say 2-pentene. I'm going to say 1-pentene because 1 is smaller than 2 and the double bond occurs between 1 and 2. Therefore, we can say that this is a 1-pentene. But what else? What else do we have? Well, we have a triple bond occurring between carbon 4 and 5. And 4 is smaller than 5, right? So I'm going to say that we have a 1-pentene, actually not an E. This is a 4-, and what's the suffix? What is the triple bond going to do? It's going to give us a YNE. It's going to give us a YNE. So that is a 1-pentene-4-ene. Okay? So let's break this down. This occurred because we have, first of all, it's a pentane. Pent means 5, so there's 5 of them. 1, 2, 3, 4, 5 carbons. There's a double bond. And that double bond is kind of important, so we're going to put it right here in the front. The N shows that there was a double bond. So whenever you say N or ene, however you want to pronounce it, that's a double bond. Now, the 4-YNE shows me that there's a triple bond, and that triple bond occurs between carbon 4 and 5. We say 4-ene because we use the lowest number. In this case, 4 is lower than 5. We're not going to say 1-pentene-5-ene. That's incorrect. We say 1-pentene-4-ene. Another way that this could be shown on the exam is 1, or not 1, we say pent 1-N-4-ene. Notice that this number 1 right here kind of smudged itself between the pent and the ene, right? So that's another way you can do it. It's just transferring numbers. It's not too bad. I actually prefer this one. This is how I roll. Maybe you prefer the other one. I'm not sure. But we're going to be practicing both styles in this video. If you have just halides or simple alkanes, right, like methyl, ethyl, propyl, and you have a triple bond, you're typically going to start at the triple bond. So triple bonds are more important than halides. So we will say 1, 2, 3. This does not count. If you want to see a blown up image, it is Cl, chlorine, or carbon, carbon, triple bond with a carbon. So indeed, there are only 3 carbons in this molecule. And there's a triple bond, so we know that this is going to be propyne, right? Or propene, however you pronounce it. And there's a chlorine on number 3. Therefore, we say 3-chloro. Now, where does the single bond occur? The single bond, or the triple bond, occurs between 1 and 2. We will say 1, right? 1-propyne, right? Or you can say 3-chloro, prop 1-ine. However you prefer 3-chloro 1-propyne, that makes more sense. 3-chloro-prop 1-ine also makes sense because this shows me that there are 3 carbons. This portion right here means that there's a triple bond. The triple bond occurs at bond 1 and 2, or carbon 1 and 2, and the chlorine occurs at carbon 3. So if you want to verify something, read your answer and then try to draw it out either on the paper or in your head. Does this make sense? Does the name that I give it map out the structure? If it didn't, then you're gonna have to do it again. If it did, then you're most likely correct. So practice both styles, right? This one is a tricky one. You'd probably do 1, 2, 3, 4. But you know, that's not too good. That's pretty bad. Don't do that. I'd rather have 1, 2, 3, and 4. But why? Well, yes, it's true that, you know, triple bonds are more important than halides, but notice something. You gotta notice something. No matter where we count, this double bond is always, or this triple bond is always going to have what? It's always going to be on the 2 and 3. If you count from left to right, it's going to be in 3, 2. If you count from, if you count from right to left, it's going to be 2, 3. And if you count from left to right, it's going to be 2, 3, right? It's the same thing, left or right. So that doesn't matter. What matters is, would I rather have a chlorine on number 1 or a chlorine on number 4? Well, I'd rather have a chlorine on number 1. The triple bond is always going to be between 2 and 3. Think critically on these types of problems. Therefore, we will count from right to left. Alright, well, we have 4 carbons. If you want a blown up image, it is this right there. Alright, so that's 4 carbons with a chlorine. Therefore, you would think it's butane, but it has a triple bond, so it's butene. And there is a chlorine attached to the first carbon. We will say 1 chloro. Where does this triple bond occur? It occurs at carbon, we're looking at the red, by the way, we're looking at the red. It occurs at carbon 2. It's between 2 and 3, but we'd rather use 2 because it's a lower number instead of 3. So we will say that this is a 1 chloro 2 butene. But then we can also say this is a 1 chloro, we're going to smush this together, but instead of saying YNE, we will put 2 and then YNE. So this tells me that this has a 4 carbons. This is 4 carbons. It has a triple bond, which is the YNE, that occurs at carbon 2. And there's a what? There's a chlorine attached to carbon number 1. This is, whenever you just have simple alkanes, like methyls, right here, this is a methyl. Well, the triple bond is going to be a lot more important, right? It's going to have 1, 2, 3, 4, 5. Okay? And we have a 4 methyl, and we have another 4 methyl. Therefore, we say it is a 4, 4. That means there are 2 things attached to the 4th carbon. 4, 4. Oh, that's a mood. 4, 4 dimethyl. 4, 4 dimethyl. And we have a triple bond, right? So where does that triple bond occur? Does it occur at carbon 2? Or does it occur at carbon 1? Well, it occurs at carbon 1, right? And we have 1. This is a 5 carbon molecule, so you would expect pentane, but it's triply bonded, so it's a pentene, or however you pronounce it. Pentene. Right. So 4, 4 dimethyl 1 pentene. We can also have a 4, 4 dimethyl I don't know. I just think it's really cute. I actually like it a lot. I'll start doing that more often. Dimethyl pent, and then we shift the 1, Y-N-E. So that is a 4,4 dimethyl pent 1-ene. If you were to see this, if I asked you to write out the molecule, you would realize, you read this from right to left, really. You realize that pent means 5, so I need 5 carbons. Now there's an yne, pentyne. So there's an yne, that means that there's a triple bond. That triple bond occurs at carbon 1. And then we have 2 methyl groups, but where do they occur? They occur at 4,4. So both of them occur at carbon 4. And sometimes you have to be happy or sad. It's perfectly fine. Okay, so we're kind of changing gears here. We're not going to start at the triple bond. No. Whenever you have an alcohol is going to be super important. It's more important than a simple alkane. It's more important than a double bond. It's more important than a halide. And it's more important than a triple bond. Alcohol is what drives you. Alcohol is super important. Right? In both chemistry and all parts of the world, alcohol makes us alive. Therefore, I'm not going to start counting here. No, I'm going to count at the alcohol. And if you want an image, it is like this. Okay, so we start counting like this. 1, 2, 3, 4. Well, you have a what? You have a butane, because it is 4 carbons, so you're expecting a butane. But then you have a triple bond, so it's going to be butene. Butine. It's really hard to pronounce, butine. Okay, but that doesn't really help me out. Like, we have an alcohol, so where does that factor in? Well, first of all, focus on the triple bond first. So this triple bond occurs at 3. It does not occur at 4. We want to use a smaller number. 3 is smaller than 4. 3-butine. But we don't have the E. Okay, we don't have the E. Instead, we have a 1-OL. So here's a vowel, and here's another vowel. If you wrote it as butyneol, right, that's kind of ugly. It's pretty bad, right? It looks really bad. I'd much rather have a butynol, right? But in our purposes, we're going to put a number between N and OL. Of course, this can look even uglier. We can say but 3-wine OL, yne, right? So again, we just shift the 3 between but and yne. Right? So again, if we were to look at this word, this name, we have butyne. Well, but means 4, so I'm expecting 4 carbons. Here's an ol, that means an alcohol, and it occurs at carbon 1. There's a triple bond in this butene, or in this butane molecule, and the triple bond occurs at carbon 3. If you have just simple molecules or simple substituents, children, we always start at the triple bond. 1, 2, 3, 4, 5, and 6. We have a 5-methyl. And this is hexane, but we have a triple bond, so it's going to be hexene or hexine. So this hexine occurs at 1. Therefore, we will say that this is a 5-methyl. 1-hexine. And of course, the other way you can say is 5-methyl. Hex 1-yne. So this shows me that we have a hexane because there's 6 carbons, but we have an yne, so there's a triple bond. The triple bond occurs at carbon 1. We also have a methyl substituent. This methyl occurs at carbon 5. Now this is probably the hardest one in here, but if you just take your time and break it into smaller pieces, you'll be fine. Okay, we have an alcohol and we have a triple bond. Alcohol is really important to me, so I'm going to focus it. I'm going to start counting first in this direction. So I'm not going to start saying 1, 2, 3, 4, right? Because then what about this? I'm not going to say that. Instead, I'm going to count nearest. I'm going to say 1, 2, 3, 4, 5. Well, that means that this methyl group is on carbon 2, and this alcohol group is also on carbon 2. So we have a 2-methyl, and we also have a 2-alcohol, or 2-ol, something, right? Yeah, actually, that works. So 2-alcohol, you can have 2-ol. Okay. And we have a triple bond occurring at carbon 4. It's not happening at carbon 5 because 4 is smaller than 5, right? So let's bring this all together. Let's bring it all together. We have a 2-methyl 4 dash, well, this is a 5-carbon molecule, so you're expecting pentane, but it's a triple bond, so it's pentyne. So 4 pent. Oh wait, but don't forget about your alcohol, right? Don't forget about your alcohol. Pent. And then we don't have the E. We're going to drop the E when we have an alcohol and put 2-ol. So this is a 2-methyl 4-pentyne 2-ol. And this could look a little bit uglier if we do 2-methyl pent 4 Alyne, right? That's how you say Alyne, and then 2-ol. It could be 2-methyl 4-pentyne 2-ol. It can also be 2-methyl pent 4-Alyne 2-ol. Right? All we're doing is that we kind of took this number and squashed it between the pent and the Alyne. All right. So the logic here was, here's an alcohol. We're going to count nearest to the alcohol. So that's from left to right. There's a 2-methyl and also a 2-alcohol. We do not say 2,2-methyl alcohol because that wouldn't sound nice. It's not good. The alcohol is going to have a lot of importance, so it's going to be in the back. It's going to be as a suffix. A suffix is something you put at the end of a word. Therefore, we have a 2-methyl. We put it in front. The triple bond occurs at carbon 4, so we have 4-pentyne. We don't have the E right there. We drop the E and put the location of the alcohol. That is a 2-ol. And of course, you could put the 4 between the pent and the Alyne. That's perfectly fine. Whenever you have a triple bond at the end point of a molecule, let's say that there's more junk trailing off towards the left, if we have this portion at the end, there's nothing else attached to it, we call that a terminal alkyne. That's a terminal, I'll just say T, alkyne. And this H that you see here is pretty special. This H is pretty special because we can call it a acetylenic, very hard to spell, acetylenic hydrogen. And notice that a triple bond, if you remember, it has a lot of S character because this has 1, 2 things attached to it. So it has 2 things attached to it. And the carbon, the central carbon, has an S character of 50% because it is sp hybridized. And because it has a S character of 50%, it's more acidic than a single bond and it's more acidic than a double bond. In fact, the pKa for a triple bond, bonded carbon, is a value of 25. So it's going to be kind of easy for the hydrogen to be ripped off. And when we rip it off, it's going to be called, well, let me draw it first. You're going to have a lot of junk right here, then a carbon, triply bonded, but we have a negative, and the H is somewhere else. But this molecule that you have here after doing an acid reaction is called an alkene. It's called an alkynide ion. And I mean, it's pretty good. Like it's the best one for carbons and hydrogens. It's better than a single bond and it's better than a double bond, right? Also, this portion right here, you can also call it as a ethynyl. Like, is that how you pronounce it? Ethynyl? Scientist, right? They're very pretentious, very pompous. And I mean, that's pretty much it. If you're asked on an exam, you know, what do you get when you rip off a hydrogen? Well, you get an alkynide ion for this molecule. I guess you could do the last one, which is a CH3C triple bond. That. So if you have like a methyl or whatever is attached to this carbon, and you were to name it, right? Here's another way that you can write it out, right? Well, that's called, well, there are 3 carbons in total, so you're expecting a propane, but we're going to call it a propanide, called a propanide ion. The ion part comes from the negative, right? The negative gives the ion suffix. So you're expecting propane, but it's propanide. The YN comes from the what? Comes from the triple bond. So these triple bonds are acidic compared to their brothers or siblings, and you should be on the lookout for them. Again, I hope that this video helped you out doing nomenclature, right? I hope that you do amazing on your next exam and that you continue to watch my videos. Thank you.